Okay, so this is the second video for the Graphs of Polynomial Functions, section 10.4, part 2 of it, and we have 2 more graphs that we need to continue on with. So if you feel pretty confident in doing this, you could always go through it on your own. Pause the video, go through it on your own, and then just check your answer. You can fast forward and check your answer. If you're not confident in it, we can just go through it together. Okay, that's up to you. The same would be true for example, number 3. You can try it on your own and then fast forward to check your answer and only watch what you need. All right, so whenever we do a problem like this, we should always start out with the end behaviors first. All right, so first of all, I always look at the exponent. In this case, my degree is 4 because the highest exponent is 4, which means that this is an even exponent, and since it's even, that means the ends go in the same direction. So either they're both going to go up or they're both going to go down, and the way we figure that out is based on the lead coefficient. So in this case, my lead coefficient is negative. So I have a negative lead coefficient, which means that both of my ends will go down at the end. So I kind of like to sketch that on my graph just to remind myself that means this end should go down, and we should also have this end ending down as well. Then I can go ahead and deal with the x and y intercepts. The y-intercept's the easiest, so I like to start out with that first. Okay, so my y-intercept, remember if I'm looking at my y-intercept, my x should be 0. So I'm going to put 0 in place of the x in all of these and then just solve. So we would have, well, h of x is just a fancy way of saying y equals negative 0 to the 4th plus 2 times 0 to the 3rd plus 3 times 0 squared. And you could go ahead and type that whole thing in your calculator, but I know this would give me 0. 0 to the 4th is 0 times 2 is 0. 0 to the 2nd is 0 times 3 is 0, so I know that my y is 0. So my y-intercept is 0, 0, and y-intercepts, it always crosses, it doesn't bounce. So remember, you need to describe what happens at those key points. So now I know I have a point at 0, 0, and it's going to cross at that point. Don't know whether it's going to go up or down, so we're just going to leave that point there. Then we can go ahead and go on to the x-intercept. In fact, I'm just going to kind of draw a divider line here so we know what went with each problem. So the x-intercept means that the y value is 0. So I know that 0 equals negative x to the 4th plus 2x to the 3rd plus 3x squared. So this one I'm going to solve by factoring. And the first thing I'm going to look for is a GCF. Now remember, since my lead coefficient is negative, my GCF has to be a negative. And there's x's in all of these, so I'm going to take x, and the smallest exponent is 2, so my GCF is negative x to the 2nd. So I would need 2 more x's to get to negative x to the 4th, so that's x squared. We would need a negative 2, so that negative 1 times negative 2 is positive 2. We need 1 more x to get to the cubed. And negative 1 times negative 3 would give me positive 3. And we already have enough x squared, so we're done at that point. So this equals 0. And again, I would try to factor this. If I can't factor it, then I can use the quadratic formula. But I feel like the quadratic formula takes a lot longer to do. So I would go ahead and I would try to factor this. So since the lead term is 1, I can think about what multiplies to the last, which is negative 3, and adds to the middle, negative 2. So that would be x minus 3. And x plus 1, and we still have our negative x squared out front. So this gives me x equals negative 1. This gives me x equals 3. And in this case, it would have been negative x squared equals 0, so you'd divide it by negative 1, which doesn't change anything. So x squared equals 0. And when we square root it, we know we're going to get 2 solutions because my exponent is 2. So I have x equals 0 with a multiplicity of 2. So my points are x is 0, y is 0, with a multiplicity of 2. X is 3, y is 0, and that one just has a multiplicity of 1 because there's only one of those. And x is negative 1, y is 0. Again, there's only one of those, so that would be a multiplicity of 1. And remember, since my highest exponent is 4, I should be getting 4 solutions, and I have 2, 3, 4 solutions. So now I can plot those points, and I need to think about bouncing or crossing, right? So if it is an even multiplicity, that means that it bounces. So this one bounces, this one crosses, and this one crosses. So at -1, 0, it's going to go across, and since it's going from the down, we're going to go from the bottom up through there, right? And then it's going to cross back here. So I know eventually it's going to come back down, but I don't know if there's a maximum or a minimum here. So we're going to have to look at our graphing calculator to figure that out. But then we're going to come back down this way. And at 0, 0, it bounces actually. So we're going to bounce here. 0, 0, it bounces. And at 3, 0, it should cross back down, so we know it should be coming down. So in the end, we end up at the bottom. So again, there's probably 2 maximums here that I'm going to have to find, which means I'm going to need to get my graphing calculator out to go ahead and figure out how high up those go. So y equals, and in this case it is -x to the 4th plus 2x to the 3rd plus 3x squared. So we're going to graph that. All right, so just like suspected, it goes through 3, but it's going to come straight down when I look at this. Right? So we have some sort of maximum happening here that's above, then it bounces back, and then it looks like it goes way up and comes back down. So I'm actually going to zoom out on my graph, because right now my graph only goes, if I look at my window, -10 to 10, and it went higher than that. So maybe I'll put -20, because I need to see the maximum if I'm going to be able to calculate the maximum. Oh, oops, I just looked at this, and look at it made it -20 this direction, which doesn't help me here. I actually needed my y to be -20, so I'm going to go back to my window. We were okay with the x minimum being -10. Now I needed it to be higher, which means my y, my maximum y has to be bigger, so I'll make my maximum y a +20y and graph it. Oh, something went wrong. Let's look at my window again. X minimum -10, x maximum 10, fine. X minimum -10, I tried to make it 20, but it changed it to 2, so we'll graph that again. So sometimes when you're playing with the window, you'll have to play with it multiple times before you see what's happening. So now I'm going to have a maximum that's happening here and a maximum that's happening here. So we're going to go ahead and calculate those local maximums, because, well, this one's an overall max, but this one's just a local max. So we go to calculating the trace, and I'm looking for a maximum. And I think this looks like the maximum, so I'm going to go a little to the left of that. This is my maximum, a little to the right. Press enter again, and it says that that maximum is happening at -0.69, and y is 0.54. So I can go in here at -0.69, which would be between here, -0.54, somewhere around here. So that initial thought of my graph is correct, that it looks like that. Now we're going to have to figure out what's happening up here, so we need to find our overall max there. So again, we're going to calculate the maximum. Okay, I think that's the max, so I'm going to go to the left of there a few. Then I'm going to go back to where I think the maximum is, go to the right a few. Oops, probably a little too far. Press enter, and so that maximum is happening at 2.19 and 12.4. So 2.19 would be a little bit over here, and then all the way up to 12 a little bit further. So now that brings my graph all the way up here and back down, and I know that it's happening steeply, so I'm just going to keep that steepness going. And now my graph here looks like my graph here, because I also calculated my maximums. All right, so let's look at example number 3 now. So same sort of idea, right? We're going to have to go through and talk about the end behavior first. Since it is even, we know that it's going to go in the same direction. And since my lead coefficient is positive, that means they're going to both end up. So both ends up. So I know at the end, both ends should be up over here. So now that I'm done with my end behavior, I can work on x and y intercepts. So my y-intercept, remember that means that my x equals 0. So that'd be y equals 0 to the 4th plus 6 times 0 to the 3rd plus 9 times 0 squared minus 4 times 0 minus 12. Well, again, these will all zero out, but I'll be left with that negative 12. So y equals negative 12. So my point is 0 comma negative 12. And it crosses. So now I need to start thinking about my x-intercepts. Now because this was a 4th degree, this one's going to be a little bit more difficult because I can't factor this. So remember, x-intercept means that the y equals 0. So it'd be 0 equals x to the 4th plus 6x cubed plus 9x squared minus 4x minus 12. So in this case, I can't actually factor by grouping because there's more than 4 terms. That means we're going to have to do like we've done in the past to find the zeros, which means go back to our calculator, clear it out. So we have x to the 4th plus 6x to the 3rd plus 9x squared minus 4x minus 12. Okay, so we can go ahead and graph that to get an idea of what it looks like. And I'm going to actually go back to a regular window. So I'm going to go zoom standard. There we go. So it takes me back to a basic window. And I notice that I can't see the bottom of this. So that means I have to go further down on the y. So maybe I'll go to like negative 15 or negative 20 on my y. So we'll go to the window. We'll make that negative. Let's make it negative 20 and graph it to see what happens. All right, so now I have a better idea of this, but it seems way too small and I can't quite see what's going on there. So I'm going to go back to my window and instead make it negative 15 and see what happens. All right, so that's a pretty good graph. So I need to find my zeros. I need to find my solutions. So just like before, we're going to go to calc, and now we're finding our zeros because we're finding where the y is 0. Well, it looks like it crosses here, so I'm going to go to the left. So this looks like where it crosses the x, so I'm going to go to the left of it a few. Go down to the right a few. And it says x is negative 3, y is 0. So I already know that x equals negative 3 is a solution. And then I can go ahead and use synthetic division to figure out where I'm at from there. So negative 3, so that'd be 1, 6, 9, negative 4, negative 12, negative 3, 3, negative 9, 0, 0, negative 4, and 12. So that zeroes out. That's good. This gives me, now it was a 4th, so now this is x to the 3rd plus 3x squared. I don't have an x term. And then minus 4. Well, again, this is not one that I can factor, so I'm going to have to use my graphing calculator again to find another intersection point. And since over here seems like there's too much going on, I'm going to find the 0 that's over here first in hopes that it'll be clearer. So we'll calculate the 0 there. And I'm scrolling over. Okay, so I think that my x-intercept is here. So right now I'm to the left of it. Now I can go over, and now I'm to the right of it. And this is an x-intercept of 1, so x equals 1. So now I know x equals 1 is another problem, and I can go ahead and do synthetic division with 1 as my solution. So x to the 3rd is 1, x squared is 3. Remember, my x term was 0, so I need to bring the 0 down. And then the negative 4. So we bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. Negative 4 plus 4 is 0, which leaves me with x squared plus 4x plus 4. Now this looks like something I can go ahead and factor. So since my lead coefficient is 1, I can think about what multiplies to the last and adds to the middle. So multiplying to 4, 2 times 2, and that also adds to 4. So we have x plus 2, which means that my solutions are negative 2, negative 2, and negative 2 again. So one of my y-intercepts is at, or x-intercepts is at negative 3, 0. This had a multiplicity of 1. Since 1 is odd, that means that it will cross at that point. Then my next one was 1, so 1, 0 is a solution, and the multiplicity is 1, so again it should cross at that point. Then we also had negative 2, but that happened twice, so we have negative 2, 0 with a multiplicity of 2, so that means it will bounce at that point. We also haven't put in that the y-intercept, so 0, negative 12 happens here, so it should cross there. Then we also have negative 3, 0 here, which means that it's crossing, and that's my furthest to the left, so it's going to be coming in from here and going this direction since we said it had to start at the top and go over. Then x is 1, 0, so this is going to have to go all the way down to here. It might end up going even further, I don't really know, but I know at very least it's going to come down to here, and then it's going to have to come back up to this point. Oh, I missed my negative 2, so that's not accurate, so I'm going to use a different color. So at negative 2, it bounces, right? So it's got to come down from here, go back up to bounce, and come back down this way. So that red is incorrect right now. So then let's look at this and see how this looks on my graph, because it should come back up this direction. So we'll go to our graphing calculator and look for minimums and maximums. In this case, that looks like it is the max, this point here, but I need to find out where that minimum was. Where did that dip? So we're going to go ahead and calculate our minimum. Well, this one's a minimum too, so why don't we just start there? So we're going to go to the left of that minimum, to the right of that. So now I have a minimum. Well, this one's going to be a local. This one's an overall minimum, but there's also going to be a local minimum up here, and it happens at 0.18, negative 12.4. So we're going to go a little bit further down here before coming back up to this one. Then we have to find this minimum, so we're going to calculate the minimum again. But we're going to go and say, okay, so this is the minimum. Go to the left. Go to the right. So that one was at negative 2.7, negative 0.54. So negative 2.7, 5.4 is here. So in the end, my graph looks more like this. So we come all the way here, we cross, we go to this point and go over, go back down and up. All right, so real quick, you should take a moment because your homework tonight and other assignments will ask you to do matching problems for these. So in other words, they're going to give you a series of problems where it's equations, and then they're going to give you a bunch of graphs that could be the solution. And instead of having to go through all this process with them, if it's matching, you can literally just go through and do process of elimination, identify the end behaviors, make sure that it matches, identify any like y-intercepts, make sure that it matches. If that still doesn't work, then go ahead and find the zeros. But these two things, this talking about end behavior and that y-intercept, should give you a really good way to eliminate a whole bunch of options so you only have one or two left. All right, so read through that as you're doing the matching activity to make sure that you know what you're doing with it. And then your last item is to actually attempt this last problem on your own, and we'll go over it in class tomorrow.